test, and it's actually a test that's put together by the book. I did use the book's test bank to create your actual test, so that the level of questioning will be very similar to this, but there will not be the same questions. Okay, so just kind of keep that in the back of your mind. But if you look at number 1, I've already told you what the answers were, but let's make sure we understand it. In this particular question, what's the best way to collect the data when we're talking about an internet search engine here? A sample survey would be the best. Why could we not do a census? How could we census everyone in this situation? It wouldn't be possible, would it? Anyone who uses the internet? Like, no, not possible. So we can kind of eliminate some of our answer choices. Why does an experiment not make sense? What is it missing? A treatment, okay? So we can kind of eliminate some answer choices as we go through, and those two can be eliminated right away. What about B versus C? Was that where our question maybe have lied, the difference between the two? Simulation, we're not going to simulate it. We can actually do it. But when we're trying to figure out the ease of using something, we're looking for some feedback. We can't really observe it. It's something we have to ask. Would you agree? We have to say, how easy was this search engine, and get the feedback. So the difference between a survey and an observational study, you're just observing, you're not interjecting your voice at all, whereas a sample survey, you're asking for some feedback, some specific feedback. So that's why this one would be a B as the correct answer there. Okay? Any questions about that? All right, number 2, we have this 1, 2, and 3 kind of a Roman numeral question here. We have a Gallup Youth Survey. We have a telephone poll of a random sample of teens, and we're looking for their favorite movie from 2004, and Napoleon Dynamite had the highest percentage, which is true. Okay, so if you look at number 2 here, we're looking for, actually I think they're all true, aren't they? The population of interest is all U.S. teens. 8% is a statistic. It's not a parameter because it's based on our sample. And the sampling design is pretty accurate because it's a random sample. Would you agree with that? The only thing you have to be careful of, and the only thing I could agree with, did anyone pick D in this case? Okay, and I might have chosen D2 as well, but because what's the only issue you might see with here? When you do a phone survey, what's true? People could hang up, and so they might not choose to respond because you're annoying them. They call their house, and especially if you live in Miss Mackert's house, where you hang up on you all the time. But so that's the only issue. Anyone see that as an issue for you? You had that bias there could have been introduced. So in this particular question, I probably would have accepted either D or E. Okay, but the book says E is the correct answer, but Ms. Mackert thinks that Roman numeral 3 it should provide a reasonable, but there is some bias there. Would you agree? So to me, I think that the book says E, but I could probably go with D. Okay. Any concerns, questions, issues? All right, number 3. It says, suppose your local school district decides to randomly test high school students for ADD. Not that that's even remotely possible for a school to do, by the way. Only a doctor can do that, but that's just kind of interesting. There are 3 high schools in this particular district, each with grades 9 through 12. The school board pools all of the students together and then randomly samples 250 students. Is this an SRS? First of all, yes, it is. So we can rule out D and E. I know it's an SRS because I put everybody together. It's kind of like thinking about putting everybody in a hat. Would you agree? All the names are together, and we're collecting a group. So I know it's an SRS for that reason. But why is it? And I venture to say that you probably said either B, if you got it wrong, you chose B rather than C. Is that true? Okay. So let's talk about SRS. If you're collecting a group, and this is a group of 250 students, that means that each group of 250 students has an equally likely chance of being selected. This is just like the question from your quiz, right, where the things came off of the assembly line. It's the exact same type of question. In order for it to be an SRS, whatever your sample size is, each sample of that particular size has an equally likely chance of being selected. That's why it's an SRS. Okay? So we've seen that question twice now. Any questions about that? All right, so the answer would be C, correct? All right, let's look at 4. A basketball player has 70% free throw shooting percentage. Definitely not Shaquille O'Neal. Okay. Which plan could be used to simulate the number of free throws she will make in her next 5 free throw attempts? Okay. So 70%, it ends in a 0. So what does that mean we can use? Single digits. So we know that. So we can look at that 0 through 9. I think all of the answer choices say 0 through 9 here. 70% means that we need 7 out of 10 of those digits to represent she made the free throw. Would you agree? So I'm looking at the next, 5 free. So this question, if you look at number 1, we're looking at free throws. Well, my question is that if you know a little bit about basketball, this question can kind of be misleading because are you talking about sometimes you only have to shoot 1 free throw, sometimes you have to shoot 3 free throws. Depends on if you're in how many fouls they have and that kind of thing, right? So you have to kind of be careful that maybe your knowledge of the sport doesn't kind of mull your answer choices here, okay? So that's why I say 1 shot, 2nd shot, but now we're talking about 5th shot. Don't you think that number 1 kind of doesn't make sense? Because it doesn't make sense, okay? I agree. There's nothing. We have to have some kind of. When we assign our digits, we have to assign them in the thought process that some of them are going to be making shots and some of them are going to be missing shots. Okay? So number 1 doesn't even deal with that. So I agree with you, Marcel. That's a great way to even look at that. So now we're only dealing with questions 2 and 3. So what we're looking at here, it says 0, 1, or 2 represents missing a shot. Is that correct in terms of the percentage? Do those add up? Because we have 3 out of the 10, so 30% misses. Well, if we have a 70% free throw percentage, that means she does miss 30% of them. Would you agree? So far we're okay. 3 through 9 represent making it, and then we're going to generate 5 numbers and count how many are in the 3 to 9 range. That sounds reasonable to me. So I think number 2 would work. Remember, there are more than one way to simulate, so let's see if Roman numeral 3 works as well. So far so good, because we've assigned the digits the same way as in Roman numeral 2. But what are we doing? Generate 5 random numbers, 0 through 9, and how many? Oh, so the only difference is ignoring repeats. Do we have to worry about repeats in this scenario? We're not assigning digits to anything. It's not like we're Hilda handing out coats where we have to ignore repeats, right? Right, so it doesn't really matter. So ignoring repeats is not essential here. So this B would be the correct answer. Okay? All right, number 5. Make sure I'm hearing. More dogs are being diagnosed with thyroid problems and have been diagnosed in the past. We have 50 puppies without thyroid problems. Keep records of their diets for several years and see if they develop them over time. What is that? What kind of a study is that? Marcel? It's prospective. When we're taking a group of subjects and we follow them over time, that is called a prospective study. What's a retrospective study? When we look backwards into something that has already happened. So for example, if I wanted to study all, I don't know, quarterbacks that got benched after throwing 4 interceptions, even though they're 39 years old, Peyton Manning, just kidding. He's garbage. Just kidding. He's a great quarterback. He'll go in the Hall of Fame, but he had a bad game yesterday. Anyway, my point is that you can look back in the past. That's retrospective, something that's already existed. Prospective means you follow into the future. Okay? Good. So what was that? That was C. Okay? Good. Oh, by the way, good job, Redskins. I would have expected no less, Davis. Davis has got his shirt on. Come on. He can represent. Good job. Hey, I'm a Ravens fan. I gotta tell you, we stunk it up. Face mask, last play of the game. What's up with that? All right, anyway. Here we go. Shh. Sorry for the football, like, shh, whatever. All right, number 6. Shh, guys. A chemistry professor who teaches a large lecture class surveys his students who attends his class about how he can make the class more interesting. Well, it's chemistry. I guess you could do an explosion in the front of the classroom and send people to the hospital, but that would be terrible. Hoping he can get more students to attend, this survey method suffers from. So what's wrong with what's wrong with the way he collected his data? Marcel? So the people that actually come to class probably have a different opinion than those who didn't come to class. Those who didn't come to class probably think he's boring to begin with. And those people are the ones that we really want to get the results from, right? They're going to have a different kind of answer than the people that are there. So what kind of bias is that? Under coverage, right? There's a whole group of people that are missing, right? It's suffering from something that not everybody is represented in the survey. He's only asking those that are in the class. Okay? Anybody put B? No? Do you have a question? Sorry, it's right here. Go ahead.
If he's only asking the ones that are in the class, couldn't that also be response bias?
No, response bias is when you you're leading the question to elicit a specific response. Response bias means that you're like the way you're asking it, the wording of the question. That's what response bias is. Okay? But nobody picked B? Chris, did you pick B? No. Shh. Because he's only asking the people that are attending his class. You'll see when you go to college that not everybody goes to class. I'm not saying you should all attend every one of your classes when you go to college. It's under coverage because the people that are still his students that aren't there are not being involved in the survey. There's a group that are missing. Okay? Cameron? No, the reason why it's not B is because non-response bias means you did ask them, but they chose not to respond. Okay, he didn't even give them a chance to respond. Okay, that's a good question. That's why I wanted to. True. Yes. A missing group. Yep, that's exactly what it is. Perfect. All right, placebos are tools for. Okay. So let's make sure we understand. So first of all, what is a placebo? It's a fake treatment. Would you agree? Okay. And what we do with a placebo is they don't know whether they're getting the treatment or not. And so what is that? A source of blinding, because you don't know, right? Now, placebos are often used as a control group. Would you agree? But it's a tool for blinding, okay? Well, placebos they act as controls often, but they are a tool for blinding, okay? Because you don't know whether you're getting it or not. Okay, good. Double blinding. I really like the boot example where it was one of the practice questions that y'all did last week, where you had to figure out which treatment, or I guess the new treatment, the weatherproofing treatment on your boots. Remember that question from last week? So I like that as a source of a double blinding. The person that's evaluating the wear of the boot should not know which boot got the new treatment. And the person that's wearing the boot doesn't know which one got the treatment. That is an excellent example of double blinding, okay? Somebody knows which one got it, but the person that's doing the evaluating of the wear of the boot or the weathering of the boot would not know. Okay, so double blinding in experiments is important such that. So let's go through this 1, 2, 3 situation again. The evaluators do not know which treatment group the participants are in. What do you think about that one? Right, that's what I just said, right? Okay, so yes. All right, the participants do not know which treatment group they're in. Yes. No one knows. Well, someone has to. Would you agree? I mean, somebody knows. So it's just 1 and 2. Okay? All right, 2 more. Which of the following is not required in an experimental design? Blocking's not required. It's a good thing to do if you have groups that are alike. You want to put them in blocks, but blocking is not a required. Control, randomization, and replication are all required. And that's why I say sometimes blocking, but it's definitely not a required one. All right, last one on the multiple choice, and then we'll get to our short answer here. And I'm going to actually do these in 2 videos. So if you're watching the videos, the first video will be multiple choice, and the second video I'll do in my 6-block class, and we'll do that with the short answer. A researcher wants to compare the effects of a new type of shampoo. The researcher believes that men and women may react to the shampoo differently. So because of that, what does he need to do with them? Block them. Okay, so we're going to block by gender. Additionally, the researcher believes the shampoo will react differently on hair that is dyed. Okay, so people that dye their hair, like myself, because I'm gray. Okay. The subjects are split into 4 groups: men who dye their hair, men who do not dye their hair, women who dye their hair, and women who do not dye their hair. Subjects in each group are randomly assigned to the new shampoo and the old shampoo. So this is what kind of experiment is this? First of all, is it completely randomized? No, because we blocked by a couple of different things, haven't we? Okay, so we know it's not A. Completely randomized mean we don't care about gender, we don't care about whether they've dyed their hair or not. So it definitely is not that. It has 3 factors. So we got to figure out what's really happening here. What am I controlling? What am I controlling as the experimenter? The type of shampoo. That's it. Would you agree? I'm not controlling anything else. I can't control whether Joe's a boy or a girl, right? I can just control the type of shampoo he gets, okay? But that's important. I'm making that as a general statement because I think that's what you need to understand. What you control is the factor in the experiment, okay? So because I can control that, so how many factors are there? There's only 1. So haven't I eliminated all the answer choices but the one I want at this point? So I control a shampoo and that's it. There are 2 blocking. I'm blocking twice. I'm blocking by the gender, and I'm blocking by whether the hair is dyed or not. Now, what if that one factor had different levels? It doesn't in this case, but give me an example where I could have multiple levels within an experiment. Again, it's something I control. So I could control whether you wash your hair once a day, or once a week, twice a week, the number of times you shampoo. Wouldn't that be something I could control, right? So that would be a different level that you could add into the factor, okay? So you'd have 1 factor, shampoo type, and then the levels would be the number of times you would shampoo. Are we okay with that? Because it's something I can control. All right, so the answer here is E. All right, I'm going to stop the recording for multiple choice, and then we'll do a separate recording for the free response.